Hello, my name is Hayden, and I am on a team with John and Nate. We are addressing the problem of leaky gas nozzles and what issues come with the drips that come out of the end of the gas nozzle after you're done pumping gas. There are 248 million people driving gas-powered cars in the U.S. This means that they all stop at the gas pump about once a week, sometimes more if they're driving longer distances, obviously. With this comes the small but extremely annoying issue of leaky and dripping gas pumps that happen after you take it out of your car. Gasoline drips onto your cherished vehicle and causes damage that nobody wants. This happens for reasons that are obvious, but gasoline acts as a solvent that strips protective wax, clear coats, leading to stains, discoloration, or even permanent damage over time, especially with prolonged exposure or repeated spills and drips from the gas pump. To define this problem, we kind of had to observe it in where it actually happens, and each member of our team has experienced this problem, whether it's from pumping our own gas or just observing the gas stains in other cars. This is a recurring problem, which is hard to avoid and happens nearly every time we pump our gas, which is at least what we noticed. And our team feels strongly that this problem is worth solving and marketing to a larger audience of motor vehicle owners. Through some general market research, our team has discovered that there are nearly no new technologies in the gas pump industry and to improve the experience of pumping gas. More specifically to the gas drip, though, is what we're noticing is literally just on the end of that spout is something that could have great improvement. Due to this, our team decided that it was a market worth improving because it's a common issue. Due to that little innovation, it could be easily solved. Through our development of new products and ideas, we will work to increase the cleanliness of pumping gas for all. As cars continue to develop and evolve with shocking new technology, most gas stations have stayed relatively the same, with the same inefficient issues just as prominent as they were for people 20 years ago. This includes the problem of leaking gas out of nozzles after fueling is completed. Another thing that this affects, there's many issues that come with this problem, but the two main ones that we noticed are a fire hazard, actually, because having flammable gas that leaks inside of your gas hatch and stays there is not good, and as it leaks onto the ground at the gas pump is also not good. And then the other part of it is just wear and tear on your vehicle. Having gas drip onto the exterior of your paint or even just anywhere inside that gas hatch is not good. And it's just annoying. Our team especially noticed that after you're done pumping gas and you pull the thing out and there's just drips every single time. It's just a nuisance that we're tired of dealing with, and we think it could be easily solved. Gas pump nozzles have to endure a lot of abuse between constant reinsertion into a vehicle, fill pipes, handling my customers, and exposure to weather extremes. It's no wonder performance issues tend to come up occasionally. And with that, we know that our product has to be very durable, reliable, and easily to be changed out if that's something that we go with. And we take into account all these factors, and they're all being used to develop the best solution.
So for our 2.2 description and estimation of the market size, we focused on mostly just the U.S. We realized that this isn't only a problem in the United States, but when we just focus on the U.S., it helps us to narrow in our target audience and make this part, just a little bit easier and more generalizable. So obviously, gas-powered vehicles, even with the use of electric vehicles now, gas still rules the market. So a couple of our statistics, we found that 68.7% of people drive themselves to work every day. This is equivalent to 198 million workers in the U.S. So obviously that's a huge number, and it shows that a lot of people need gas. Additionally, there are 211,000 gas stations in the United States alone, so obviously our product would be useful across a majority of the population, and this is kind of important when you're discussing the market size. So we have a map here that shows the density of gas stations across the U.S., and obviously it shows less gas stations out in the West. We recognize this to kind of be a combination of more diesel fuel being used for long-haul trucking. So that's just, a little bit different. Obviously, there's still a lot of gas stations, and just diesel pump is a different type of, is a different way to use our product. So with so many gas stations in the United States, gas consumption is wildly increasing. We found that almost 134 billion gallons were purchased in 2012, and obviously this number is rapidly increasing with the population. Since 1950, gas consumption in the U.S. has tripled. We only predict this number to keep growing. So now we kind of focus on the modern fuel pumps and where it goes wrong so that we can hone in our product to be useful. The modern fuel pumps are pretty complex, and the leaks rarely occur within the motor pump body itself. A lot of times it's just like connector pieces. So a couple of the ones we focused on were deteriorating seals and gaskets. A lot of times this can happen and they harden, shrink, crack, or become brittle after years of temperature exposure and constant fuel. Damaged fuel line connectors can crack as well due to impact, stress, or aging. And then the metal connectors themselves can be corroded. The failed tank gasket, this often happens due to improper installation of the lock ring, and this leads to like leakage around the flange. Although, these kind of focus on, we focused on more like regular gas pumps. Diesel trucks drive a lot, obviously, and they do hundreds of miles per day. So diesel fueling pumps can experience like more prolonged fueling and greater quantities, so this results in more wear and tear, and just sort of another reason to use our product. Here's our summary of Element B of the design and development project. Alleviate the problem of gas spillage out of a nozzle. Although there's been some progress in the design of the pump and handle itself, there has not been much innovation in the individual nozzle, which is where our problem stems. The average person pumps gas 1 to 2 times a week. When you factor in the dangers of excess gas just laying around the pump, as well as decrease in the overall cleanliness, this becomes a much bigger problem. One of the most popular current solutions is the automatic shutoff nozzle. The general idea is that the pump automatically stops the flow and seals the outlet whenever it's disengaged or shut off. This product is around $85 and is made of aluminum with nickel plating, so it's durable and can survive the conditions. The groundbreaking aspect of this product is the Venturi tube at the top of the nozzle, which has a sensor to send a signal to the flow tube telling it when to shut off. Some of its pros are its durability and spill prevention features as explained above. It was also redesigned to be more comfortable for the user and can be customized to whatever company chooses to purchase it. Two of the biggest issues are that it's expensive for companies that aren't large corporations, and it still doesn't address the issue of excess gas spilling from the nozzle itself.
Another existing solution to this problem is the nozzle check valve. Throughout the gas pump system, there are several check valves that work to keep a pressure gradient inside and outside the pump and stop air from backflowing into the system, so only gas comes out when the nozzle is triggered. The check valve in the nozzle is a spring-loaded mechanism which can only be opened when the pressure inside the system is greater than outside and the nozzle is triggered. After fueling is complete, a sensor signals the check valve to close, which stops gas flow out the nozzle, but like the Venturi tube from the previous solution, it leaves some gas residue down the length of the nozzle because the valve is located too far up in the nozzle, which is what causes the leaking when the nozzle is pointed down.
The first patent that we looked at was the flow stop device. The flow stop device basically just regulated the flow of gasoline that exited the gas pump to provide a uniform flow from a pressure source that varied. The vent on the nozzle will eventually become covered when there's too much pressure and trigger the vacuum to stop the flow of gasoline. The second patent is the stream shaper. This device is an add-on to the tip of the gasoline nozzle that has several waffle-like holes to manipulate the exiting gas, just to make it more controllable. The critique that we had for this patent is that all the ridges on the tip of the nozzle may slightly better the flow, but with that there's a large amount of excess gas that becomes trapped after the flow has been stopped, and with that it just leaves a lot to drip onto the exterior of your car after you're done pumping gas. The overall goal of these two patents is to better control the amount of gasoline that comes out of the gas pump. And the final patent that we looked into was the vapor recovery fuel nozzle. This basically just recycles excess vapor after the gasoline is done being pumped by a pressurized vacuum. And there's a large problem with this one. The problem is that the vacuum quits too early and could be a lot stronger. If it were, the nozzle would be able to not only recycle the vapor, but it would be able to recycle the excess gas strips as well. Because at this point, the recovery stops short of recycling excess strips, which is a large problem.
Next up in our design process was designing a mold for our prototype, which we used Fusion 360 for. We first designed it on the program and then 3D printed it in a plastic material that would be compatible with the silicone that we are dumping into the mold. But some of the problems we faced when pouring the silicone and actually using the mold we designed was that the silicone stuck too much to the top parts of the mold. So we had to use pliers to get the mold out, and that kind of wrecked the mold. So in the future, we're going to work on designing a mold that is easier to pull out the prototype from so that we don't have to wreck a new mold every time we make a new prototype. And some of the features of our mold that we created were originally we had pegs on the top that would help align the mold to the silicone so we have a uniform pour every time, as well as we put indents in the slits at the bottom of the mold, which helped us for cutting the silicone prototype after we printed out the mold. And we also put slits in the top of the prototype to help excess silicone leak out of the top in case we poured too much when we were forming the mold.
So for the pour itself, we ended up using the mold that we made on Fusion, and then it was just 3D printed. It was kind of more like a test, and we weren't really sure how it was going to end up coming out, even though it worked in the end, but we weren't really sure at first, and we were just kind of getting a hang of the silicone. So that took a while to get used to. We had to pour the silicone in like a 1-to-1 ratio so that it would come out the right consistency and end up sticking on our actual product. The first couple of times we screwed it up because the first time we didn't pour it right, and we dumped too much silicone into the mold, so it ended up flowing out the top, and then we just kind of had to restart. But then the next time we stirred it the correct amount and we dumped the right amount of silicone in, and then we ended up having to wait a couple days, so we weren't quite sure how it would come out, and it stuck originally, but it ended up coming out just like we wanted it to.
So the last part of our prototyping process was assembling the mold to the gas pump. We started with basically just the blank piece of silicone mold that came out of the blue 3D printed mold. And then from there we cut the hole over the emergency shut-off valve deal that then would shut off the gas pump. And then from there we also cut the end of it. We cut the flaps in it so that when the flow is when the pressure of the gas is great enough, it would break the seal on the end of it, output gas, and then when the flow rate became weak enough to when you're done pumping gas, it would then close the seal and close up the gas. And on here you can kind of just see how we slid it on and then used a metal clamp to clamp it on. And it works. I mean, it looks well, and we are not ready for testing. Other than that, there's not much that we did. It's snug around. There's good thickness on the end that you can see in some of those pictures. The thickness on the end is greater than the thickness all around. And it covered kind of that whole blank part of the end of the gas spout. So now next up is testing.